Today let's try to build a clock, or not in this video but basically in future. Basically it will take many days and many videos to build a digital clock, but at least you will learn something. I have lots of these 4017 chips, lot of these laying around, and they are getting kind of old, they are getting rusted, so I should use them somewhere. So basically I will use them in a clock. So I'm going to build a clock, and the clock is going to be simple. I'm not going to use a crystal. I'm going to use my mains as the clock frequency source. So first let's try to divide the mains by 5. Then in the next episode I will basically hook up this chip with the display and try to basically divide the mains by 10 and try to basically drive this display. And in another episode I will try to basically make the whole clock in a board, or I will purchase some 0 PCB per board and solder the chips and display together and build the clock. And I will buy a smaller transformer, of course. This is kind of big, and it is from my inverter project, triple VF single phase inverter project. I am also planning to make a 3-phase basically inverter to drive 3-phase induction motor, and I'm going to basically design that using this chip, or at least some binary counter. But first let's try to build a clock, because this is the simplest project I can build right now. So I can turn on the transformer. Actually I should explain the schematic, how I am going to build the power supply and the clock source for the clock. So basically this is the transformer I will be using, or this is an example transformer. You can use smaller transformer with low voltage. So how will it be working? Well, this is the iron core and this is the secondary winding. I am connecting one of the transformer output directly to ground, and other goes to some resistor. I'm using 18 kilo ohms here. You can use higher or lower resistance resistor here. Then it can go to some basically clamping diode, some capacitor, then to a transistor, and the transistor can have 1.5 kilo ohm resistor from some regulated voltage like 4 volts or 6 volts to the collector of it, and it will give out a good nice square wave of 50 hertz. For the regulator I am using 2 transistor contraption. It is quite simple. This transistor is controlling the base of this PNP transistor, and the PNP transistor is the power transistor. So how it is working? Well, let's say you have 2.5 volts here. This transistor is turning on from base to emitter. This transistor is also turning on from base to emitter. So the voltage on the collector is going high, so the voltage on the emitter is going high, and as the voltage from base to emitter is decreasing, the base of the PNP transistor current is decreasing. So basically that's how the feedback is working, and the voltage will settle. So basically 2.5 volts goes to the base of this transistor. So expect basically 2 times minus 0.6 or 0.5 volts base to emitter voltage drop, and that will be your output. It will be crudely regulated, but I don't have 785. For dividing the 50 hertz by 5, I'm using one of the CD4017 chip. The pin 1 is the pin basically Q5, and the pin 1 goes to the pin 15, which is the master reset pin of the CD1417 chip. Pin 14 is the clock pin, and it is directly connected to this transistor, and this transistor is clocking the chip, and you have a good 10 hertz signal at pin 10. So this is the circuit I built on the breadboard. This is the regulator, voltage regulator. This is the clock generator or clock processor. Of course, at this point I should call it basically some kind of triggering circuit, not processor, but anyways, it is giving a good 50 hertz pulse, and I can actually probe on it. You can actually see 1.5k resistor here, and let's try to turn on the circuit. And of course, if both of these resistors are of same value, they basically multiply the base voltage by 2 minus 0.6 or 5 volts. But I'm using 1.7 kilo ohm resistor here, so I will have high voltage here, about 6 volt, or 6.2 or 3 volts, which is actually okay for this chip. Hope for no explosion. And I'm probing on the collector of this transistor, and you can see a nice 50 hertz square wave, and of course it is coming from the grid. Now I want to probe at the output of the chip. Now you can see the 10 hertz signal here, 10 hertz pulse or 9.99 hertz pulse, and it is not 50% duty cycle pulse, but this will work. Of course my clock will work with this pulses, or any clock will work with this pulses. And you can see the regulated voltage 6.33 volts. Should I look at the regulated, basically unregulated voltage or rectifying voltage, or the rectifying smoothing capacitor voltage? Well, it will be higher, I guess. It is about 19 volts, which is quite high for the chip, of course, and any other circuitry. It is at 6.32 volts. Thanks for watching the video. I hope you liked it.